Hello everyone. Welcome to my YouTube channel Chemistry Quest. This is the fourth lecture on polymers. So, in this video, we will be discussing some important points such as what is a natural rubber, what is vulcanization of rubber, what is synthetic rubber, and what are biodegradable polymers. So, these four things we will be discussing. So, first is the rubber. Rubber, we all know that it has elastic properties. So, rubbers are of two types. First is the natural rubber that is obtained from nature, and later we will be discussing the synthetic rubber. So, natural rubber is a natural polymer and possesses elastic properties. That is, it can be stretched. That is why it is also known as elastomeric polymer. So, in this polymer, chains are held together by weak intermolecular forces. Because the intermolecular forces are weak, that is why the rubbers possess elastic properties. A few cross links are introduced in between the chain, which helps the polymer to retract its original position after the force is released. This is about the natural polymer. Next, we have to discuss about the monomers of natural rubber. So that is isoprene. So how we have to remember the structure is, first we have to remember what is butadiene. 1, 2, 3, 4. Four carbon atoms. Diene is 1, 3 comma diene. So first carbon is this, second and third, and this is fourth. So this is first, this is the second carbon. This is having single bond. Third carbon will have double bonds, and this is 2 methyl. So the second carbon will have a methyl group, and rest positions are filled by hydrogen atoms. This is about the isoprene molecule. This is the monomer of natural rubber. So how it is manufactured? It is manufactured from rubber latex, which is a colloidal dispersion of rubber in water. So latex is obtained from the rubber tree, which is mainly found in India, Sri Lanka, Indonesia, Malaysia, and South America. So natural rubber is a linear polymer of isoprene. The common name is 2-methyl 1,3-butadiene and is also called as cis 1,4 polyisoprene. So this is the natural rubber. So here also CH3, this is the CH3 of methyl group. Here this is this CH2. So here it leads to a free valency. Here this free valency is connected to another CH2. In this way, natural rubber is formed. Now we have to discuss some properties of the natural rubber. The cis polyisoprene molecule consists of various chains held together by weak van der Waals interactions and has a coiled structure. Therefore, it can be stretched like a spring and exhibits elastic properties. So, next we have to study vulcanization of rubber. What is vulcanization of rubber? We know that natural rubber has the property that it becomes soft at high temperature, that is greater than 335 Kelvin. If it is heated, it becomes soft, and brittle when it is treated at 283 Kelvin or less temperature than that, it becomes brittle. So this is the quality of natural rubber. To improve upon these properties, that is, the natural rubber also shows high water absorption capacity, and it is soluble in non-polar solvents and non-resistant to attack by oxidizing agents. To improve upon these physical properties, a process of vulcanization is carried out. Now, what is done in this vulcanization process is that the raw rubber is mixed with sulfur, and an appropriate additive is added at a temperature between 373 to 418 Kelvin. This is very important. 373 to 415 Kelvin. So, what happens during vulcanization? Sulfur forms crosslinks at the reactive sides of double bonds, and thus the rubber gets stiffened. How it happens, you will see with an example. So this was 1, 2, 3, 4. This was hydrogen. This was hydrogen. This was methyl. This was double bond. This is also double bond. Here also one hydrogen is there. Here also two hydrogens are there. So this is the isoprene structure. So what happens here, where there is a double bond, here it forms a reactive center. The double bond gets converted to single bond and a sulfur bridge is formed. So this is known as vulcanization of rubber, right? It can be done in two ways. First is a simple one. Two isoprene units are joined together. Second is the first carbon of the isoprene unit is connecting with the first carbon of other isoprene unit with a sulfur linkage. So this is known as vulcanization of rubber. Now next we have to discuss about the synthetic rubbers. So what are synthetic rubbers? When we change some properties of monomer of natural rubber, we get synthetic rubbers. So as we know that in isoprene we had a methyl group at the second position, but in chloropene we had chlorine at the second position in 2 chloro 1,3 butadiene. This is the monomer. It undergoes polymerization to form the neoprene. Neoprene is the synthetic rubber. It has superior resistance to vegetable and mineral oils. It is also used for the manufacturing conveyor belts, gaskets, and hoses. This is about the neoprene. Next, we have to discuss about the Buna N. Buna N. What is Buna N? Buna N and Bu is derived from butadiene. Buta 1,3 diene. Bu is derived from there. Okay. And N has come from acrylonitrile. So how it happens? It is basically a co-polymerization reaction. Why? Because there are two different monomers. The monomers are not same. So first is 1,3-butadiene, that is the first monomer, and second is acrylonitrile, that is the second monomer. Okay. So in presence of peroxide catalyst, it undergoes polymerization reaction. So here the double bonds will become single bond and single bond becomes double bond, and it leads to the formation of Buna N. So where is it is used? It is used in making oil seals, tank lining, etc. This is about the Buna N. Next, we have to discuss the biodegradable polymers. So in biodegradable polymers, we have to study two polymers. First is the PHBV and second is the nylon to nylon 6. So what are biodegradable polymers? So if the polymers are not degraded by the action of environment, it is responsible for accumulation of polymeric solid waste materials. These solid materials caused acute environmental problems and remain undegraded for quite a long time. In view of the general awareness and concern for the problems created by polymeric solid waste, certain new biodegradable synthetic polymers have been designed and developed. So basically, biodegradable, why they are made? Because to save our environment from harmful polymeric waste. So first is the PHVB and second is nylon 2, nylon 6 is mentioned in our NCRT. And one more thing is important is that aliphatic polyesters, they are the important classes of biodegradable polymers, right? So how this PHVB is formed? First we have to remember the name of this compound. Poly beta hydroxybutyrate co-beta hydroxyvalerate. This is the full name. It is obtained by the copolymerization of 3-hydroxybutanoic acid and 3-hydroxy pentanoic acid. Okay. PHPV is used in specialty packaging, orthopedic devices, and in controlled release of drugs. PHPV undergoes bacterial degradation in the environment. Now, we can refer to its reaction. We have to remember two important monomers of this reaction. First is the 3-hydroxybutanoic acid. So, butanoic acid is 1, 2, 3, and 4. This is a 3-hydroxy. And this is 3-hydroxy-pentanoic acid. So we have to count from here 1, 2, 3, 4, 5. Both are 3-hydroxy. When these react with each other, right? It leads to the formation of PHBV, right? So next we have to study about nylon 2, nylon 6. So what is there in nylon 2 and nylon 6 is that in nylon 2, nylon 6 is the full name, complete one name. So there are two monomers. First monomer has two carbon atoms, two carbons, and second monomer has six carbon atoms, and it is also a biodegradable polymer. So let's see with an example, nylon 2, nylon 6. So as we have mentioned that this is first carbon, this is second carbon, this is the structure of glycine, right? And this is amino caproic acid. It has six carbon atoms, five from methylene group and one is the COOH group. So from here, these two monomers, glycine and amino caproic acid, they undergo polymerization under some conditions of temperature and pressure are very essential, and it leads to the formation of nylon to nylon 6. This leads to the biodegradable polymer formation. So this is all about this video. If you like this video, please give a thumbs up, share with your friends, and subscribe to my YouTube channel. And don't forget to hit the like button. Thank you.